Should we start?
Yeah, sir. Do continue, sir.
ठीक. Sorry? Hello?
Yeah, sir. Yeah. Now continue, sir.
Okay. Sharing my screen again. Let me know once you're able to see it. Any questions till this point, like blog content and stuff? Anyone? Okay, let's continue. Hello. Yeah, okay. Let's continue. We'll start with forms now. So Flask, as I said, Flask has a lot of extensions that you can use to extend, what do you call it, systems. Should we wait? There are quite a few people. Yeah, let's wait for a few minutes.
Hey Saurabh, are you there?
Yeah, I'm here. Should we start?
I guess we can start because it is almost 20 minutes. So
Yeah, yeah.
yeah, please begin with the. Satya is also not joined. Is Satya
He
there?
said he will join in a bit.
Okay, sure.
So coming back to the point, Flask WTF. As I said, uh, Flask has a lot of extensions that we can use on top of the basic features that it offers. Flask WTF is a form management plugin, you can say, or library that will help us to create forms, manage them, keep it secure and stuff. So to like get on with it, we'll just install this Flask package. And before that, so the thing that we were trying, sign up page. So we already see quite a lot of time. I say if you're already signed up, just click on login. So if I just click on login, it basically redirects me to the login page. The code for this here in the app.html, sorry, app.py, it's like this. This is the URL for function. I just created a Python simple variable, stored that information, and then we have it in an A tag in HTML. So this helps us basically to redirect it. Coming back to the point, Flash WTF. So we'll just install it and then create a login form and try and see data on it. So WTF is now installed. Now, Flask WTF has some security features in it that basically don't allow you to intercept traffic and change the form data, because login and all of these forms are quite, what do you call it, critical functions. So if at all someone does, say you're signing up and someone intercepts the request and changes the data in that request, so your account, the password, they can check it, they can basically perform actions on behalf of you. So for that, we have this CSRF functionality. So to use that CSRF functionality, we have to set up a secret key inside the application. I'll just go here and set this up, the secret key. Config, and this can be any random key actually. You can just have anything. Now we'll create a login form. So simple login form. These are all the different type of fields. So first line we have the Flask form. So this is the form object. So in HTML you see the form block FORM. So this is that kind of a thing. This is the backend for it basically. So we'll just import it. And we have WT forms, different fields. So as we are creating a login form, we need a string field that will be used for our username or say email, password field for our password, that is like understandable, and submit field to get the submit button. So I'll just add it here. So we want some, if you want to run some validations on the data, which we'll do later. So for example, if the password has say certain number of special characters, certain number of password, sorry, certain number of length and everything, all of those things that can also be set using these validators. You're adding a required field over it, required validator, because right now to get a basic understanding of a login form, we will definitely need a username and a password. Without that, we cannot log in. So just the required validator is something that we are using. And we are creating a form. A form can be created using a class, simple Python class here. And we just put our fields, use those to basically get the login setup. Now we already have our @app route login with the get and post methods. So we will just copy this. I'll walk you through what these components do. The login method that we created previously. Let's replace this with a new code. So the first two lines remain the same. The first two lines remain the same, and we have login form, this class that we have created over here using the class form as a base. We are using that to create a form variable. And yeah, okay. We also need flash. So let's see what these are for in a bit. Let's show in duplicates. So we are checking if the form, and we'll check the values that we are getting in the form if they are valid on submit and everything. If valid, so we have a validator here that is data required. So we'll check in that function if we are getting the username and the password. Only then we'll let it proceed to the login. So for now we'll just flash this like with what do you call it, a simple page and stuff, nothing else. We'll just have like a, what do you call, a simple pop-up which say it will just show user and then password and stuff. Then this, it is redirecting to the index. We changed the index function, so I'll just rename it to home. Here we have this home function. I just changed it to that. And all of this will run if we have, say, a valid form. If we don't, then it will just show us the login.html with the form, this form variable. Now I'll go back to the front. We have this page, so I'll just copy it. And I'll create another template called login.html. Paste our content in it, save, and the Python code. Yeah, it's running here. Okay, so we'll go to the login page. We have here our form is rendering. So this is basically rendering based on these. Now we have specified that this is a string field, this is a password field. We never added, say, text box or something like that in the HTML itself. But Flask handles that for us and it creates this label as well as this text box. So what I'll do is I'll say test and test and I'll just submit. It redirects me to the home page, and if I go in the terminal, I'll see that I have this post call. If you want, we can just close this, print this as well. Instead of flash, I can do print. So if I go back, login, type this, login requested for user test, comma test. So this is a simple login form that you can use, get your users logged into your platform, your website, for example. Any questions till this point? Okay. We'll continue. With setting up the database. Now we have login form, but this form is basically not getting us anywhere. This form, just prints the data and that's it. That's the end of it. So what we want to do is we want to connect to the database, store a user, then from the database basically authenticate that user based on the credentials stored there. So let's copy this, get it installed in our environment. And we'll set this up. We'll just use a SQLite database that will just simply run here itself as a file system, but there are different kinds of databases available, so we can use those as well. For example, MySQL that you may have more commonly heard of, MySQL, MS SQL, PostgreSQL. Then MongoDB is a NoSQL database. Ideally for users and all of these kind of operations, we prefer to use these kind of databases, so MySQL and structured basically SQL-based databases. You just import this. Create a DB variable from SQL Alchemy using the app variable. So this basically helps us create our database items. Now we'll create a model for our user. Okay. The structure for this can be in different files, but just to keep it simple, I'm just creating all of it in one file. We'll go over what these structural practices are later on. So we have this now. So what we want to do is we want to have the ID which is automatically created, email, username and password. These are the three fields that need to be created and stored in the databases from this form. So we'll modify our login form. We'll add one more field to it. Again. So email as such as a field we have added over here. 1, 2, 3. These are the three fields that we'll be using. So now what we want to do is the data that we get from these forms, we want to push it to the database. So that is basically a create operation. So it will look like this. So user, username, email, password. These are all the fields that we are basically creating. So similar to ideally this. So just give it a minute. Sorry. So sorry, my bad. So we created this login form, but instead this we can call this sign up form. We'll create a sign up page and create sign up form. Similarly, we login form only needs the name and password. Similar to the login page, we'll use a sign up page. Request shared for source user. Now, ideally, we don't want to print all of this data out, but just because we are testing and it makes it easier for us. So we have the sign up page. Now we'll just create this similar to the login HTML. We'll create another file called the sign up HTML. In sign up, we have three fields, that is username, email, and password. So we'll just add email. setting up HTML. We'll use that here. Also use an F string to do these operations. Just let's run the code again. Let's scroll it up. Go to the sign up page. We have 3 fields. So I'll just say this, and it redirects me to the home page, and I can see that this username and password comes up here. And all of this is fine if you're just printing it. Now we'll perform CRUD operations on the user data that we are getting. We'll go back to our page. We now have a form that collects our email, username and password from the user and sends it to the backend. Now what we want to do is use this credentials and all of these details and add it to the database. To do that, we'll just copy these 3 lines. And we'll go over these lines one by one. So previously we created a class called user. This is basically an SQL Alchemy model that connects us with the database, and that database has 4 columns: ID, username, email, password. So these are the 4 fields that we are going to set. ID is automatically generated because it's the primary key once we perform a create operation. So this initialization of this object, this class, and creating this object, we are doing it. Now these are static values. What we will do over here is pick these values, and paste. That was the username. Now we'll paste and change it to email. And last but not least, we'll set the password. Now this creates an object that basically creates, that has the details of the new user that is signing up. So we have this user, we add it to the database, and we perform a commit. So the commit will basically write the data to the database. Till this point of time, we have just created a DB object but we have not added it or closed on it. Closing the connection, you can say, or committing the data. So now that it is set up, we'll just run our code again, start it up, because the changes that we are making causes the cluster, the server to crash, because in between the intermediate changes also it tries to refresh. I go back to the sign up page, test google.com, test as the password. What does it say? We get an error. No such table user. Alright, yeah. We'll have to get the table created. Sorry, just give me a second. Yes. No changes in the library, I think. Maybe this should work. Getting an error. Yeah. The user was created. Sorry. Sharing. Sorry, my bad. Yeah. Google.com. Yes. Transparency. Get this. So password user test one sign up requested for so answer user and this object is now added to the database. Now what we'll try to do is we'll try to log in that same user again. For that, we'll perform a read operation and check if that particular user is present or not, and if it is present, then is the password correct or not. We'll just go ahead and this. Compare the username that we get in this value. Now, the idea is that the user, this first, it basically returns as a list, and we want it to. So sorry, it basically returns as a value. If this does exist, like if it has something inside it, then the user does exist. So what we'll do is we'll just write a simple if statement. If user is none, means if the user technically does exist, then we'll check if user dot password is equal to form dot password. So we can just say user successfully logged in. Else we can say wrong password. User does not exist. We can say it's not found. Save this. Go back to the browser. Go to the login page. Right. Save a username test. Test. Its user successfully logged in because it was able to find that user in the database. But if say you also have a user called test1, but if the password for test1 is testing. Now if I just say test, it will say incorrect password. If I write test2, this user does not exist. I will write the password. This user not found. So these are the basic level of validations that you can do while you perform login. So these are two operations called create and read out of CRUD. So CRUD basically corresponds to create, read, update, delete. Now there is also the case, say, where a user sometimes wants to update their email or update their password, for example. So let's create an endpoint for that. And sorry. So for any basic input operation on a user password, what we normally do is we'll take the existing password and we'll take the new password. And we'll also need the username, for example. So we'll just create a form similar to what we have for login, for example. Except in this case, we'll have three items. That is, one is the username, one is the password, the third is the new password. So copy this, press enter, paste. You can call it reset password form. We have username, we have password. And we'll just add one new field called new password. Now we want to use this form in an HTML file. It will also need a route. So we have sign up, login, but a third one, say reset pass. So we can just use the login one, because a lot of things with login will be same, as we'll have to check if the user does exist, if the user does not exist, the password is incorrect. All of that logic will still remain the same. Just the end update, if the user is successfully, we are able to check if the password is valid and the user does exist, we'll just update that particular form, password field for that user. So paste. Now we already have login, so just change. So form validate, so this is login form, we'll change that to reset. Third, reset requested results. String for so-and-so user, so-and-so password. Now, if the user, this does not exist anyways, we'll just go for user not found. If the user does exist, but the password that they have shared is wrong, then we'll just say wrong password. But if, for example, the user is successfully, basically has the correct password and they are getting the correct username as well. So what we'll do is we'll update the password here. So to update the password, we'll go back. So here it says user.email. Instead of that, we'll just set it to user.password and add the new password then. So user.password. Here's the form. For reset password, we'll again need a new template. So for that as well, we'll just copy the login, paste it, and reset pass, we have two password fields. One is the main password and one is the new password. Change just your this is use the same here. So we are using this reset pass HTML here. We'll start the server up and go to the reset pass endpoint. Let's see username, password, and new password. Then try and change the password for this test user. Password was test. I'll say the new password is test. Save. Yeah, it basically changes in user sense. We have kept this and change this. Change. If I try again with this, test one, this is wrong password because now the password has changed to test one. Then ESP2 file. Say 1, 2. Password change was done. We'll go back to login. Is it successfully logged in? All of our data is being stored in the database and we are able to pull it from there. We are now able to perform create, read and update. Next operation is delete. So for example, there are people that come up and say we don't want to keep our account on your website and you want to get it deleted and stuff. So let's create a form for that. The form will be pretty much similar as reset password because we need to again log in, reset password, all of these things. We need to verify if the user is valid or not.
Saurabh, do you have an extension to view the data in the SQLite? In the VS Code?
We should. We have not.
It should be there.
Sorry. SQLite viewer, I think this.
I think viewer is more interesting to see the data in.
Graphical format.
Yeah.
Okay, let's see if this works. Yeah.
Yeah. So this is how your data is looking in the
Data. We have this table with all of these columns.
And have you spoken about different databases which can be used in class?
Yeah, Postgres, MySQL, Mongo, any database basically.
Do we need any specific drivers to access them, or Windows can access them default?
SQLite can be accessed by default because it is just file, but once you try and install Postgres, MySQL, the drivers do come installed.
Okay. There, we need to have some drivers from pip again, right?
Yeah, the libraries, yes.
Libraries. So any questions, anything so far? We have covered create,
Read, update.
create and update.
Create, read, update. Yeah.
Create, read and update. Okay. So now you're creating the form for delete.
Delete, yes.
So you see how quickly so many files have grown now, and keep a track of all this is very difficult. That is one of the reasons we suggest to have GitHub repo and all. So all of you by end of tomorrow or day after or end of these sessions, I would like to see all this been created in your repos. Okay. Okay, sir. Continue.
Yeah. So reset password. Reset password. Paste it. And we'll try to create another form called delete user. So on that, we'll just need two fields. For example, it's just the username and the password. We have this form. We'll now create a page for it. Path per se. Delete user. Delete the form. Password just to print for our sake. Then extract the user based on the username. If it does exist, same, all of these things will remain the same. We'll go back here and we have this delete user with the user block. So copy this, paste it with this. And it's successful. Now we also need to basically create this copy of this. This is ready. We'll use this form here. Use it. Run our application again. Name, password, and does say login. Let's change that. This is where it says login. insert here. Delete here. So these are the submit buttons. Delete user, it should say delete. Login, it should say login. For sign up, it should say sign up. Go back and refresh this page. And this test user, its password is test. The delete successful. We'll go to this database and refresh it. The user has been deleted. So create, read, update, delete. 4 operations. Sign up. Or sign up is basically create. Login is basically reading. Then reset password is basically update, and delete user is basically deleting. 4 operations. What operations can perform. And we can also do query and count and all of these operations based on. So if you want how many users are there in a database, you can just do a count. This function, this will print, give you the data, order it in a certain manner. So let's see, this basically corresponds to that. Any questions on this? Anyone? Has anyone reached to this point?
Yeah, if you haven't reached, we can help you right now.
Yeah.
Anyone trying at all? You can leave a comment in the chat if you want.
If you are stuck, you can just pose the errors here.
Right.
Now Flask, we can continue. Flask has some authorization and say as we integrated login and stuff that now helps us with say access and everything, login, sign up. So CRUD operations we did, but say for example post login I want to if we have say an example, for example we have an application where we are creating a to-do notes. So I should only be able to access notes if I'm logged in. If I'm not, I should not be able to access it. So those things need to be managed using authentication and authorization. So we have done authentication by performing sign up and login. Now we will perform authorization as well. So for that we'll use the Flask login library. Login is now installed. App. Portrait. We'll set this up. Flask login basically needs a loader function to check the user based on its ID. So we'll just provide this. Already have our model in the same file, so we'll just provide it after this.
Which page are you on in the docs, Saurabh?
7.
7, okay. So for everyone's benefit, he has documented all the steps, whatever he is doing right now.
Yeah, you can refer to them later on.
Yeah.
Sorry. Now, to make things easier, we have so Flask login has this mixin. This mixin will handle your login, logout, and if the user is logged in, it will maintain a certain token for it. So from Flask login,
So what makes sense? Just tell him in one line, right? What makes sense?
it's a an dependent. You can say a parallel function. So for example, you're performing some operations. If you talk about it in simple terms, if I am performing login and I want to create token, I want to store it. So parallel in the background, it will perform some operations for you. So that is what a mixin does. Here we are just creating, because this is a login library, we have a user mixin that is basically connected to our model, user model. So this is our user model, and we'll attach this mixin to this model. Now, we have a login route created, and this login user function, it handles that particular user if we get, like, say, valid credentials, and as we have specified over here, we check the credentials if they are correct or not, and then if we do get valid credentials, we'll have that login user set that a particular user is logged in. So this login user function is what we'll run here. Before we have it. So this mixin, as we have connected it with the database, so this will basically say that the user has now logged in, and it will update it. Yeah, this is post validation. Now we will need like a logout path. We don't have it at this point, but yeah. So this logout path, just add it here. There's nothing, it just logs you out if you are on that, if you go to that page. This also can be imported there itself. Log out. Now we have, as I said, that there should be certain paths that are only restricted to a particular logged in user. Now about page can be, say, used by any user, for example, but post or something like that should only be used by a user that is logged in. So for that we have these login required decorators. Decorator will restrict access to a user, and it will allow only if the user is logged in on the site, only then they can access this particular site. Yes. For example, say this posts. What we'll do is we'll restart our server. Some error. This is it needs to update the requirement.
To talk about what this file does.
Yeah. So as and when we go about changing the dependencies that we use, they are also updated. If we just do a pip install, for example, we installed Flask. This will directly pull the latest version of Flask, but if we have some issue, but working on a particular version of Flask, say version 2, and the Flask library is updated. So once we again run install Flask, it will again pull the latest library. But then there may be some functions that are removed in Flask that we were using but are not present anymore, and then they can also be replaced by something. So to maintain the stability of our code, we ideally should have a requirements file. This requirements.txt file basically holds specific versions of our code for specific packages. So those that work with our code and are not basically expired, or they don't have dead code in them, something like that. So dependency is a very big issue in software engineering. When a particular package is updated and we don't know about it and functions are deprecated in them, it causes issues for the complete application to fail. Yes. As we now see, this particular URL decode function is not available in workzog URLs. So ideally we'll have to use an older version of Flask. We were using version 3 right now, but we'll have to use this. Then, although there may be a few features that are not available, but they will work. And the idea is to keep on increasing the versions while testing the code so that we know what particular part is breaking, and we can maybe find a replacement or try and update the code according to the modified library. So pip install -r requirements. This is root directory requires.txt. And we'll try to run Java startup. We'll see if all of our code works as expected. Login. We'll do S1 and password is testing. Okay, wrong password. We should verify it from here. I just typed it in. Is good. If user.password and form.password.data is the same. Yeah, should work. We'll try and create a new user. Create a new user. New. User successfully logged in. I'll try to access this post endpoint. Yeah, logged in. I go ahead and log out. Okay, I redirect it to the home page. If I try to access 40, it says unauthorized because I'm not logged in, so I'm not allowed to access this page. Now these pages can obviously be made better using say custom pages and CSS, JavaScript, but the idea is to understand backend, so I can just ignore that for misapplied incorrect credentials. So this decorator checks if a particular user is logged in or not. If they are not, then they won't be allowed to. We can similarly add this @ login required here for the delete user as well, so that a logged in user can refresh. In this then now I try and go to delete user and I'll be able to access it. Any questions? So this handles it for you, this decorator. This is a function. Documentations to basically see are also present. Any okay. So any login system has basically all of these components. So login, logout, register. Register is basically what we have created for sign up, forgot password, and reset password. Forgot password functionality basically requires us to have some sort of second factor authentication. So for example, say we send a token on the email, or in this case, as we are just testing it out, we can just print the token and get the token verified. If it is, say, the correct one, then we can just verify and push it. Else we can just what do you call it, send an email, and then the user can get that token, add it on our website, and then we can just push it, change the password for the user. And for example, reset password also we tried out. Yeah, these are the standard user flow, user authentication flows. And then there are functions. So ideal. So right now, what is happening is we are able to see raw data in the password column. This is not recommended because anyone can use these passwords and make changes. So the ideal situation or the best possible option is to hash these passwords, and on the fly when we are checking, just compare the hash. The hashes are non-reversible to the password, so that is why the password in itself is safe, and the user just shares the password and the database only has the hash. So that is one thing. We can do that. Let's try that. Yeah, now as you see, our application is getting bigger and bigger, and still, honestly, this is quite small, but the applications that we normally work with are quite large, and they have multiple, say, views, multiple codes. Like in each of itself, the application has many components that on their own perform a lot of operations. So we use blueprints to basically configure them and separate them out, use common pages components so that we reduce code duplication, and we can reuse all of these things here. So for example, we have a simple standard page as such, and we can have it say renders certain resources based on the parent page, and that parent page can then just be overriding some components of the child page. So here we have an example of creation of a blueprint, and we can just pass the page name, page content for page name. This is just a standard HTML. This is not very different, but if you go down, so admin and user. So admin has completely different set of features. They can perform user management operations, and they can also perform, say, some operations that are restricted to on the site to admins only. For example, on an e-commerce platform like Flipkart, there are multiple levels of permissions. So as the user, we are only able to say order products, view our own orders, and so on and so forth. The customer support staff has a different level of access, so you can say that we can have a block for the customer support staff. They will have a certain level of access. They can access certain features, certain pages specifically for them. Similarly, say the admin, on top of that, their manager. he will have certain level of access. Then at the top, the complete organization, like these site admin, will have complete control over it. So he will have certain permissions, certain different pages that only that particular person can access. So we'll use blueprints to access them. And this ideally is done to isolate access and say split it. If we don't want the user application to be disturbed by this, then we basically separate these components out. There are common parts among these as well. So those are outside here, but these blueprints are basically used in the main application. As and when required, if say admin is logging, only then these components are accessed. So MVT models, so models, views and templates. This is more from a architectural perspective. Static files, all of those resources specific to that particular access level or say application. Now we'll move on to creating APIs. What at the end of the day is an API? So all the sites that till now we have developed, these are all HTML based pages. HTML based sites have like a front end UI and stuff, but nowadays what we normally see is a microservice architecture. There is just one website and it basically connects to different services behind it. Now mobile applications, the application is at the end of the day installed on your device and say in the browser as well. The front end is written in say JavaScript or some sort of front end framework like React, the Angular, something like on of that line. So this particular component storefront web app. This is basically a JavaScript application that is gathering data from different services. So these data points, they are not exactly shared in HTML format. They are shared in JavaScript object notation or JSON format. We'll get to that in a second. But so JSON format is basically standardized. So the mobile app can also use it to make API requests. The browser basically, the front end application can also use it. And basically making those requests, you can get the data back. And yeah, like you can handle all of these tasks here. Instead of basically rendering all of the components here, we just get the data and render all of it on the front end itself. Even say between services, the communication, if we want, say if the inventory needs to verify something with account, as in say if this particular user has this inventory or not, if this inventory is tied to some account, that perspective. Then we have API communication, which is very structured, and there are like there is a standard format to it. We'll go ahead and build an API. We'll just install Flask RESTful. Just check if we have it in the oops, yeah, we don't. That's RESTful. Now we'll import API. We'll create a separate app for this. App.py here. Let's create API.py. The format for just this creating this is a bit different. Here we are not adding, you can say, decorators. We are just creating like function to path routings. So just although this is similar to what do you call it, decorator, it's just not exactly the same. The action that it performs is similar to a decorator. We have this API. Let's API app stop our Python application API.py API running. That's a JSON. Hello world. Ideally, we test these using Postman. Get request to this endpoint returns as a JSON object. We can also have it do like fun stuff. So let me just give me a minute. So sorry. So we'll try and use this API. Is the fund and request library. And create a request on the fly. is what APIs are normally used for. Communication between services. For example, I have one microservice, two services talking to each other using an API. That which is a very commonly used library. So what we did over here is we went to this URL. If I open this in the browser, you'll be able to see it. So we went to this URL, we pulled all of the data, and then we returned it through our API. So JSON, the idea is to return JSON. Yeah, let's do this. Request passing. So we have input data coming as what do you call it, JSON, and Flask RESTful gives us an interface to basically parse these requests and then make operations, like perform operations based out of it, and then return this data. So for example, if we have a function called greet user with a parameter, say name, we can just do this. So I'll just copy this, put a different class. We had that on the forward slash, now we have this greet. Now we'll use a path-based parameter, which is something like this. They are having this value. Yes, server is down. So if we don't set the type of request to JSON, then it does not basically reply back. So there are these hidden values. We need to set content type to application JSON. What is the error that we're getting? Name is Alice. Okay. Very condition I'm expecting value line 1 character 0. Oh, sorry. Yeah. Is it expecting it in the body? Okay. Expecting it in the body. Ideally, slash rate endpoint, it will basically respond with hello Alice. All the response and the formulation is the same. This is basically communicating in a JSON data structure itself. Let's move on to the next thing. Yeah, so then there are options to basically, as Satya was saying, we have ways to set standard error pages as well. So, for example, if you want to say set 404 errors, then we can also set those. But for example, for APIs, these are not pages that are being accessed by the user. So here a standard error response is already sent by our handler, that is Flask RESTful, but we can also customize it to some extent. Request is to the handler. And if I make a request, let's say / hello, which does not exist, it will give us this one, which divided. If I do a post request on the read, I will see this. So primarily, this is what an API does. You can perform all the same operations that you can perform on the website based part of it, that is Flask normally, and this APIs are basically maintainable because we don't have to handle data and everything. Just the front end that is separately managed, it does that for you. Here you only need to perform the logical operations, handle the authentication and all of those things, but in a structured manner, so that the front end only needs to get the JSON object. Any questions? Anyone? Am I audible? Yeah.
Yeah, you're audible, and check how many people have been trying.
Yeah. Can people? Yes. Someone was saying something.
So you have completed all the docs, or you're still left with some pages?
It's 2-3 pages, but it's more from the perspective of theory.
Theory and how to deploy it securely on production and all, right?
Yeah.
Okay. Did we write any cases, anything? No.
No.
Okay.
You have what test cases are. Profiling.
So any questions, anyone? Are you following what is happening? Okay, continue.
They're basically components that sit in between the web server and the application. They intercept like the request between the application and the server, so that if you want to change the headers, or if you want to change a particular data format, if you want to check if a particular user is authenticated or not, all of these are like a part of the middleware section. You can customize your own middlewares, and you can also add, say, proxies. So let me just Flask apps can be deployed in this proxyfix middleware, but it's more from the perspective of you knowing it, and the specific use case will depend. Then we have custom middlewares, as I said, if you want to make change to the environment, some sort of header change in the middle of the application, something or the other. So if you have intermediate changes, yeah, these can basically help you with that. Then Flask hooks are basically performed if you want to perform some action before, say, before or after the request, then you can just do those. So for example, if I have what do you call it, if I want to check if I have a custom token that needs to be checked before a request, then this particular request can be used and checked. Basically, as I said, APIs are used to connect between different resources. So if I check before making a certain request to a certain API endpoint, if that service is up or not, then post the request is complete. So if the number of connections that I can maintain with a particular database is limited, so I can just close those connections. So these are the type of functions that you can use. Then tear down request, yeah, kind of like a destructor to basically close off on a resource. As I said, the database has limited number of resources. It will just tear down the request and it will handle it even if say there is an exception in the code. So some error has occurred, but still this tear down request will handle our feature so that the application is running smoothly regardless of what we are currently doing with the rest of the context. There may be fire in one side of the building, but the other side, rest of it needs to be stable. So that is why we have these. Then app context. Yeah, this is basically running the context tear down. So if, for example, we have this @app decorator, and if you make changes to it, if you want to run some things inside it, then you can use those things. Basically tear down particular components or that are just inside the application context rather than the complete code that is running. As we use, like, there are different kinds of extensions. So we use Flask logins, we use Flask WTF, we use Flask RESTful, we also use Flask SQL Alchemy to basically connect with the database. So these are the kinds of extensions. Plus migrate is used to run data migration. So for example, I have this user model that I created and I add another field into it, say another column into it. For example, logged in or logged out or something like that. Now, since this is a structured SQL table, this has like a structured set of columns. So we cannot directly add, say, new data based on the model. It will just give us errors. So migrations are what we need to run so that those migrations will, say, create that particular column for us, and although the value can be blank, or say we can set a default value for some for the old items, or have some sort of logic that can be used to fill those values as well. But migrations handle database connections and their updations. Then next we have mail. So yeah, as I said, if we are performing, say, a reset password or forgot password applications, forgot password features, so we need to send out emails or say SMS depending on, say, the use case and the application. So we have, for sending emails, we have this Flask mail package that can be used, and we can just use it and push these emails to the user so that they can receive a token and basically forgot their password. This is primarily Then, as I said, we have a certain set of requirements that we need to set before the application goes to, say, the production environment. And this production environment, we cannot have sensitive data, and what do you call it? Different secret keys or something like that. Here we just added the secret key in the application code itself, but all of these need to come from environment variables stored in some secret format so that they are not exposed and only a certain number of people can access them apart from the code. So that is one point. Requirements, as I said, the dependencies keep on changing, and all of these files or these versions need to be tagged, and they need to have a certain specific requirement for a specific version. So there is, so for example, Flask and Flask WTF, these are connected, all of these. So it may be possible that only a specific version of Flask works with a specific version of Flask WTF or SQL Alchemy. That way, we need to tag these versions and store them in our requirements.txt file. So for that, we can use this pip freeze command and create a requirements.txt. So if I just copy and run it, for example, it will basically create this requirements.txt based on all the packages that we have installed in the current environment. So also the reason why we need to use virtual environments, so that we don't basically create a conflict with the main OS packages. Database migrations, as I said, Flask migrate, we can use handle changes in the database level. Error handling, ensure your, yeah, so here, although we did not perform error handling, but can have some exceptions being raised. To some extent, we are handling, so user-based errors. So, but the application-based errors need to be handled as well. Sorry. Save as well. Sorry. And run. Right. And this is login, right? If I give an incorrect user, basically now since it is running in development mode, it will show up like this. But if I say, for example, change debug to false, and this running. Let's say this not show that exception on the front end. But if I set it to true, then this complete goes back. So that we can debug and perform our operations. Then, so if these are different methods to deploy it to different particular sites, and Heroku being one of them. You can use Gunicon to deploy it. So Gunicon can also be used on the local environment if you want. This is the important version. You just have to specify the port. -P. Right. So this runs it in a production manner. Won't let you get all those errors. Although it will print it here, but it won't show it up on the front. This can run parallel workers so that you can have multiple instances of this running. And this is basically a server that runs your Python script. Similarly, we can use it in different environments using Nginx. Nginx you may or may not have heard. Nginx is basically a reverse proxy, and we can use Gunicon as the WSGI server so that it can run your Python code and communicate with Nginx and transfer your traffic to the end user. Directly exposing Python code can basically cause issues. So Python decouple is a library again. This basically helps you store environment variables and such files and use them in your application in this code. Email host and all of those things. To code organization and structure, this is just some best practices that I have written up that you should follow per se. So application factory is the application factory pattern to create the app functions. The ones that we have used, like meaningful names and all of those things as well, are something that you need to consider. Then blueprints, as I said, use modular components so that you separate stuff out, don't make it too complex, and it's easier to maintain for yourself as well as the application to run, because you don't need all the components to be accessible to all the users and handling authentication on each and every layer can be a headache. Instead of having different applications, you can have a single application, but with in different blueprints, so that it's restricted to certain requests. And yeah, so ideally, migrations are something you will have to use Alembic or Flask Migrate, for example, to handle these schema changes. But you can also do those things manually, although it is not recommended to do them because we are using an ORM. The ORMs do handle most of your databases. So primary queries like raw queries to the SQL database are not that common nowadays. But at the end of the day, ORMs are sensible, but they also have a certain overhead because they're automating all of the database connections for you. If you do want to create a high performance application, it is recommended to have like raw SQL queries. And yeah, so N plus one problems. This is a computer science concept. Basically, you can. It's not recommended to have queries and loops and stuff, so that because the more number of operations that you perform with the database, the slower it will be. Because at the end of the day, although the server is fast, the connection to the database and its queries is comparatively slower, because it is going and reading data from the storage. Although it is stored in a certain manner and it is accessible, but it's still difficult and say time consuming, has a high cost. Cost in this sense is the time required for the request and response. So the complete flow, the user makes a request and the response is received to the user again. This complete cycle is ideally should be kept to the bare minimum. Then password hashing, as I said, we are storing the passwords here in a raw format directly. This should not be the case. We should not do this. This should not be the case. We should store hashes. But this is easier to understand, so yes. CSRF protection. So Flash WTF by default has CSRF protection, so you don't need to worry about that if you are using Flash WTF. But if you are not, you should have CSRF tokens on each and every form-based request, so that no intermediate party can intercept the request and perform operations on your behalf. Intermediate party, I mean, so for example, if you're on google.com and facebook.com is making requests to google.com on your behalf. So that is the kind of scenario. Avoid SQL injection, use the query API, not the raw SQL with string concatenation. So right now we have we have used perform all the operations here. We have used to the user API here as well, user query API. We have not used raw SQL queries, but you need to clean up. If you are still making requests, there can be SQL injections. So SQL injections are basically raw SQL queries that users or malicious users can basically inject in the, for example, your username or password, and then they can try and access data that is not meant for them. Use HTTPS, so as it is quite common nowadays. Encryption is necessary between the host and the server because, sorry, client and the server, because intermediate traffic sniffing and snooping attacks are quite common. HTTPS certificates help prevent those because the traffic is encrypted from the source to the end. That is the server. There are different types of test suites. Unit tests are basically individual function based tests. So if I want to write a test case for sign up, that sign up, login, different test cases for all of these different features. So those will come under unit test cases. Integration test, you can say, is, for example, I sign up, and after sign up I say, what do you call it, create a post-it note, like a set of functions combined. So I'm testing here the different functionalities of the application in a single flow, that is the integration test. Then end-to-end test cases are when we use the web application testing frameworks like Selenium to test the complete flow end to end. Each and every feature is tested just like the user would use. So that is end to end. Fixtures, basically, so fixture data is like, right now we are doing all of this testing using manually. So we can write fixtures, for example, like factory boy. This is a Python package that will generate like random data for you. And you can use that data to basically push your database and run these. And continuous integration, so GitHub Actions, Jenkins, there are different kinds of tools. So whenever you make a push to GitHub, or in this case, it will basically run certain set of commands on your code base. Yeah. Profiling, Flask debug toolbar or Flask profiler to understand the bottleneck. So there may be some, say, request where you are making too long of a database call, or it is some operations are taking too long to basically run. So the profiler can help you identify those. Caching. So if, for example, you are having some sort of data that is frequently accessed from the disk, but it needs to be fast accessible, so you can use caching mechanism like Redis. So it is basically an in-memory data store. So in-memory, by in-memory I mean storing it in RAM. So this is not persistent over reboots. So anytime anything that you store in this database will not persist after a reboot. So this is just an intermediate layer for faster access to the data that you have, for example, say in the database or on your local directory, anything. And rate limiting. So nowadays there are DDoS attacks that happen, but if you are using a good load balancer, they do provide like rate limiting services. And if you do plan to or deploy it on your own on a single server, then you can think of using simple firewalls like UFW that are available on Linux itself. And yeah, Python's async library you can use to make asynchronous support with Flask. Flask also has support for sockets. So bidirectional socket communication is also supported. And you can also use Flask's CLI to basically add CLI commands. So you can just have this CLI parameters, pass it while you're running the Python application, and what do you call the Python code. Basically, when I run the Flask run function, you can just pass additional parameters and get stuff going for you. So, yeah. Any questions? Anyone? I think everyone is asleep.
Not yet.
Okay. Yeah. That's Satya.
Okay. So have you covered everything in the documentation, whatever you have written?
Yes, we have.
Okay, great. So as an exercise, shall we tell them to add CSS to the whole thing or something like that?
I would recommend, say, adding CRUD operations to perform, what do you call it, say, create some sort of post. So we have done it for user.
Okay.
They can probably do it for, say, an post or say something like a post-it note application.
Okay, something like to-do apps and all?
Yeah,
Okay.
we already have a few endpoints for those as well. So they can just copy, create a class for post-it note like that.
Okay. Sachin sir, are you there?
Don't think so.
He is there, that E-FDP, that's basically, yeah.
Was a bit heavy. Yeah.
Yeah, it is heavy. It is almost everything of whatever we have done in web development so far. And there is so much to be done, you know. There is too much, like we haven't written even test cases, we haven't run regression tests. There is so much which can happen, you know. Yeah. Luckily, it is same Python. If you go through this documentation, that is the reason it is shared in the form which it is. We just copy paste and try it out. If you have some issues, we can.
Yeah, hello.
Yes.
Yes, okay.
So Saurabh is done for today, and Lalita madam said it was very heavy today.
Yeah, it was backend today, so backend is actually very heavy.
Yeah.
Yeah, you can.
So we can close the session if you want to.
Yeah, material we have already shared, Lalita ma'am, and
Yeah, you can use this.
yeah.
Also, I'll push this code to the repo.
Yeah, push the also.
So you can share this material in the group that we have. That link.
Sure. No. Yeah. Okay. You can share it with them. Yeah.
So we'll be continuing tomorrow, or tomorrow only Ritik would be there.
Yeah, Ritik, and I have asked Anchit, like Dr. Sarabjot was not there, you know, so he has assigned one of his data scientists.
So Anchit would be joining in place of Sarabjot.
Yes.
Great.
So most probably he will join day after, or I don't know, whatever Ritik and him he decides, you know. Ritik, was you able for him?
Yeah, so we are still distributing. So most probably I will be taking care of day 4 part, like tomorrow's part, and he'll be taking care of day after tomorrow's part.
Okay.
Great.
Yeah. So in ML and AI, mostly whatever Saurav has shown right so far, and using the same stuff, we create APIs to share data, because nowadays what happens is we don't have humans talking to machines. These are all machines, like computers are talking to computers, so they have access tokens and they talk to each other, exchange data. There's so much of things happening, right? Like let's say Google has to index all of the web, right? So they cannot have manual process, people manually adding data to their indexes, right? So what they do is they crawl all of the web by using bots, and these bots go and submit this data to their repo, and then from there it is changed into whatever searches we get, the magic of the search algorithm. But in this whole process, their bots visit all of our websites, right? And that is where, again, in one of the very old things in web development, file known as robots.txt. It's such a old thing, right? Like it's still there. I don't know how many people still gave respect that, Saurabh. You can still crawl, right? Or we cannot. You are muted, Saurabh.
Most crawlers don't don't obey it actually.
Anna?
Yeah.
Oh, because everyone wants data these days, right?
Yeah.
So that's what happens, and these crawlers and these machines, and so there are nice ways of sharing data, and this data can be shared in different formats, mostly JSON, CSV, or any other format, and that is what we are going to learn tomorrow. Ritik is going to cover that, and how this data can be used for visualization and data analysis, plotting some graphs, using some libraries in Python again, and it will be very useful for your day-to-day work also in research.
So like, are we also going to talk about some pipelines and data cleaning, data engineering?
Yeah. Tomorrow and day after, yeah. That's going to be covered. Okay, and anything else? Last moment notes, anything, any questions? How many of you were able to do this? And I would like to see everyone's repository, Sanjay, Sachin sir, and see to it that people create that.
Sure, why not?
There is not much to be done, even if they create that and create those files, upload them, commit few commits, that itself will be a great practice,
So like that can be the part of your assignment, isn't it?
Yeah. So that I've been telling them since morning, right? Like everyone should have a repository. I'm going to assess them, check those repositories, and everyone should submit that. Okay. Anyway, what else? What else? Yeah, I think we are done for today.
Right. So I must take this opportunity to formally thank Mr. Saurabh today. It was very heavy and wonderful session with you. Though I couldn't attend the whole session today, but the part I attended was very interesting and very well delivered by you. Thank you. Thank you. So we are closing to the day. We'll see you tomorrow.
Yes.
Morning 9:30 a.m.
Yeah.
Okay. Bye bye.
Bye bye. Bye everyone. Thank you.